So now I guess, yeah, I guess if anyone has a question to throw at me, go for it. If not, I will do some 4.9 because 4.9 is all about planes and stuff like that. Give people a second. So I have some 4.9 questions I haven't finished, but let me look through quickly and just see of the ones that I finished. Which ones are good? So oh yeah, 4.2.16, that's the one we did just now. 4.2.4. Let's see. Yeah, this is cross product. 4.2.13, this is cross product. 4.2.14. Okay. Does anybody have something that they want me to do from 4.2.14 in Nicholson? Maybe look through that quickly, if people can. Or here, how about I just share the screen? I think if I just pull this forward, you'll see. So 4.2.14 is this. So find the plane with this. So it's A, B, C, D, E, F, G, H, I, J. Oh my god, there's a lot. Never mind. So A to J. Up here, so give people a second to read that. Anyone want me to do that? I assume you can see my screen. Yes, you can see. Okay, good. And then down here are these ones. I think I might just do J, because J is an interesting one. But if anyone else has any particular ones. No? Yes, no? Maybe not? Okay, so I will do J, just because I feel like it, and even though I've already done it, I think it's a good example for planes. So 4.2.14J is saying each point, so it's saying find the equation of the plane that where, or I should say where, each point is equidistant from P 0, 1, minus 1 and Q 2, minus 1, minus 3. So if you kind of think of this as, so it doesn't matter what point on the plane, the distance from that point to P and the distance from that point to Q will be the same. So if you kind of think about it, like here's P and Q. The plane that satisfies this is like kind of floating in between them. Right? Floating in between them. I don't know how to draw this. Right? Floating like that. And you can draw a line from, let's say we just choose this point. Let's say it's on the plane. Okay? Hold on, I'll draw this better. Like this. It's like kind of like that. Let's just say that. Wow, not a very good drawing. But imagine here, this point right here is on the plane. This distance and this distance are equal. There's this empty space there. These 2 points are not on the plane. This is P, this is Q, not on the plane. Right? So this point is on the plane, that distance there. We can choose any point. Let's just say that point on the plane. That distance and that distance in the space will be the same. So it's kind of like a point. If you look at it from the side, right? It's like we have this is P and Q, and this is the plane just from the side, right? So just as if it was just a line, right? We're looking at it from the side. It doesn't matter what point on this plane, the distance from P to Q, P to that point will be the same as the distance from that point to Q, right? Okay, so let's figure out what this plane is. So, well, first of all, let's figure out PQ, because notice the normal of this plane will be that thing, or half of it, but really the normal could be any multiple of itself. But let's just say half of it because it makes more sense here. So let's find PQ first. PQ is Q minus P, so 2 minus 0 is 2. Negative 1 minus 1 is 0. Okay? And negative 3 plus 1 is negative 2. So half of that is just 1, 0, minus 1, right? So the plane, the equation of the plane is going to be x minus y equals d, right? X minus y equals d. And let's find d. Possibly. Q minus p. 2. Yes. Yes. So that all this is wrong. Negative 1 minus 1 is minus 2. Negative 3 plus 3 is minus 2. Okay, there we go. Thank you. So again, half of that would be this, right? So that's kind of this vector right there. And so that is the normal. So it's going to be x minus y minus z equals d. And, well, so now we need to find d. We need to find a point on the plane. Well, the midpoint of p and q, right? Between p and q, that's on the plane. And so that midpoint, well, the midpoint, we'll call it a, I guess. It's going to be the average of each component. So 2 plus 0 divided by 2 is 1. 1 plus negative 1 divided by 2 is 0. And negative 3 plus negative 1 is negative 4 divided by 2 is negative 2. So that's a. Okay, since we know that's on the plane, 1, 0, negative 2, let's just plug that in. 1, 0, negative 2 equals d. Right, so 1 plus 2 equals d, so d equals 3. So our plane is x minus y minus z equals 3. Don't need that underlined. There you go. And that's the equation of the plane. Okay. Let's look at 4.2.15, B, D, F. These ones I also did. Let's see what B, D, F. B, D, F. So find the vector equation of the line. So not too tricky. Not too tricky, that's okay. How did I do F? Yeah, someone was going to say something, I think. Yeah, 4.2.15b. Yeah. So 4.2.15b is asking, it wants the vector equation of a line that passes through the point P 2 minus 1, 3, and is perpendicular to the plane 2x plus y equals 1. So for the vector equation of a line, well, we need a point. Okay, so our point is that point, plus a direction vector. And if it's perpendicular, if we're looking for a line perpendicular to a plane, well, we actually just want something, the direction is going to be the normal to that plane. Right, so the normal of this plane is 2, 1, 0. So that's the direction vector here. And that's the answer. Did that make sense? If not, then I will explain it more and better and slower. The direction vector of the line. And in this case, the direction vector is n because it tells us it's perpendicular to the plane. And n is perpendicular to the plane. Good. Anybody want me to do D or F? Don't know how I do F. I did F before, and now I'm thinking, how did I do it? Passing through P1, 1, 2, intersecting line perpendicular to that line. So somehow I have to use the... Oh. So let's do F quickly because I can't see how to do it right away. So it's saying it's passing through the point. We want a vector equation of a line passing through this point. And it's perpendicular to this line, x, y, z equals 2, 1, 0, 2, 1, 0, plus t, 1, 1, 1. So to be perpendicular, that means that the direction vector of our line, I'll call it d 1, I guess. The dotted with 1, 1, 1, right, has to equal 0. But that doesn't seem to help us. The cross product is nothing. The question is, giving a vector equation of a line that passes through that point and is perpendicular to this line. So I'll draw it. That line starts at this point, 2, 1, 0, and it goes in the direction D, which is 1, 1, 1, right, which makes up this line. So we're looking for a line that goes through 1, 1, 2. Should just be like, well, kind of hard to draw. I don't say it's like there. And it's perpendicular. So we're kind of looking for this line, right? So our direction vector, so this is D2, D1, our direction vector, or I guess I should call this D0, really. Right, so our direction vector dotted with the other one has to equal 0 because they're perpendicular. Sine of this one on the purple line, yeah. And so, okay, let's just say I know this point. I'll call it R. Let me see here. P isn't on the line though, right? P isn't on the line, so P is just in space outside of this line, right? Because the point is 1, 1, 2, so there is no solution for T because it's not on the line, right? So so that's pretty much. Someone's gonna say something there. Yes, which is perpendicular to D naught. Yeah. How would you write that? How would you? Wait, 1, 1. Oh, wait. Where's 1, 1, 2? Oh, sorry. Point P. 1, 1, 2 plus T times the direction vector. Yeah, that's what our line's gonna look like. X is 1, 1, 2 plus T times some direction, D1. That wouldn't necessarily go through the point P though, right? Because if you have a line, right, it starts at point P, I'm thinking perpendicular, yeah. Oh, I see. I think I see how we're going to do this, yeah. So, well, just to quickly finish my sentence here with this one is, yeah, we can find there's infinitely many perpendicular vectors, right? There's this one, and there's this one, and there's this one, there's this one, right? But only one of these options also goes through point 112. Right? There's only one perpendicular that also goes through point 112. So not just any works, only this one. Right? So yeah, to go here, to go into this triangle, I'll just make that triangle bigger, right? Just that highlighted triangle that I made here. So this is point 210, right? This is point P, which is 112. Okay, and this is nothing in particular. Yeah, we don't know that. But this is down here, this is the direction vector. Yeah, that's the direction vector. So we're looking for this. We're looking for this vector. So let's call this, here, how about this actually? Let's call this A. Let's call this B. Let's call this U. Right? First of all, we know that B equals the direction vector. Okay, we'll just keep that on the side. Let's think that. But one thing to notice is that, okay, U equals A plus B. Right? If this, like that. Right? U is A plus B. So if we're just looking for A, well, A is going to be U minus B. Well, oh, sorry, this is not technically true. Sorry, B is not the, no, sorry, we're not quite there yet. So U is gonna be, yeah, A is gonna be U minus B, right? Just rearranging this equation. Well, what are all these things? U is just, so U is just QP, right? Or that's not Q, sorry, just fine, let's just call it Q. So QP, right? Minus B, well, B is the projection of QP onto D, right? B is the projection of QP onto D, minus the projection of QP onto D. So first let's find QP, so it's P minus Q. 1 minus 2 is negative 1. 1 minus 2. 1 minus 1 is 0. 2 minus 0 is 0. So that minus the projection of QP onto D. So it's going to be negative 1, 0, 2. And then the direction vector. So the direction vector was the direction vector of the original line. So a 1, 1, 1. So dot 1, 1, 1 over the magnitude of the direction vector squared. So 3 times 1, 1, 1. What question? It is 4.2.15f. Okay, so negative, no problem. Negative 1, 0, 2 minus, so now this is going to be negative 1 plus 2 over 3. 1, 1, 1. Yes, it is recorded. So there. And then this is going to be just a third, right? So minus 1 third, 1, 1, 1. Okay, so finally, A is going to be, well, I'll just write it out again. So negative 1, 0, 2 minus, or, yeah, I'll just write it like this. A third, a third, a third. So negative 1 minus a third is, well, I didn't have to write A again, but it's fine. Negative 1 minus a third is negative 1 and a third. So it's negative 4 thirds. 0 minus a third is negative a third. 2 minus a third is 1 and 2 thirds, so 5 thirds. Okay, so that's A. We just solved for A. Well, notice, remember, A is this line, which is this line, which is the direction vector of what we want, right? The direction vector of our new line. So that means that our D1 is equal to that. So finally, our answer is going to be the line, the starting point, which is P, which is what they gave us. P is 1, 1, 2. 1, 1, 2. plus t times the direction vector. Negative 4/3, negative 1/3, 5/3. And there we go. And I will definitely check if that's the answer. Oh, I lost track of the question. What question was this again? 4.2.50. Gotta scroll now. Okay, 4.2.15. Oh, I'm always in the wrong section. 4.2.15. F is not what I said. 4. Oh, yeah, it is what I said. Never mind. Although negative for some reason. Yeah, it's fine. So although this direction vector is different than what's written, it's just a scalar multiple. It's just -3 times it, right? So they got rid of it. And you can do that because it doesn't matter what the direction vector is, right? Like the t will be different then, right? The t value, but the actual like span of it will be the same. But the t value to get to any one particular point will be different. But yeah. So I could have written this as 112 is our starting point. 112 is our starting point, right? Right. So and that it gives us that in the question. Okay, so that's how they wrote in the textbook, which is the same thing as what I wrote, just -3 times the direction vector. Maybe I'll just quickly explain vector equation of a line. I mean, probably many people understand it, but I feel like I have not heard any teacher explain vector equation of a line in a way that makes sense. Although I only have one teacher, obviously, so I don't have every teacher, so I don't know. But I'll just quickly explain it. Hopefully it'll be useful to someone. So the vector equation of a line, hopefully I said the right thing before. The vector equation of a line is written like this. P naught, right, plus t times the direction vector. So all this means, right, all this means is that in Rn, you choose a p naught, right, a point, some point to start at. You choose a direction vector, and any point that is on the line can be expressed as starting at that point and then going a multiple t times the direction vector. So let's say I want to get to here, right? Well, I start at p naught, right? I start at p naught, and I go 1, 2, 3, 4 times the direction vector. So you would write this as x, that point there, or I'll say that point there is p naught plus 4 times the direction vector, right? And this is going to, of course, go negative and smaller versions and like fractions and decimals and to get every point on the line. And eventually, if you go do infinitely many things, it makes the line. So that's what that's saying. Starting point plus a multiple of the direction vector. Okay, that's it. Hopefully that was helpful to someone. Okay. So just a negative t value, right? The direction vector is being scaled by this t, which is just some real number, right? And so if that's negative, yeah, then you'd just be going in the opposite direction. So this one in particular would be p naught minus 2 direction vector. That point right there. Yeah, no problem. Okay, so unless anybody has anything else they want me to do for 15, I will go on to 17, which is 4.2.17. 4.2.17. I think I even skipped 17, but someone tell me if they want me to do 17. I think that's what I'll just do. I'll just show the question on the screen, and if someone wants me to do it, I'll do it. So, this one. You can also type in the chat if you don't want to say out loud. I'll just say, yes, I want you to do that question. Otherwise, I can also do 19b. So you see, find the equations of the line intersecting the following planes. Find the equations of the line of intersection of the following planes. Don't remember doing that one, but yeah. Okay, so I take it nobody wants me to do this one. I'll do this one because can't quite imagine how I'd do it right away. So let's take a look. It probably is not too bad. Could I just... Yeah, I see how I do that. Okay, so I'm pretty sure for this one, let's just do it. 4.2.19b is asking, is that even in the question here? 4.2.19b. I crossed it out, but I don't think I even did it. 4.2.19b is asking, find the equations of the line of intersection of the following planes. And the first plane is 3x plus y minus 2z equals 1. And the other one is x plus y plus z equals 5. I don't know if this is right, but this is what I was kind of doing in my head, and let's see if it works. So I'm going to take that first equation and just make it minus 2z minus 1 equals 0. Same thing for the second one, x plus y plus z minus 5 equals 0. And can I just make this equal to each other? Minus 2z minus 1 equals x plus y plus z minus 5. Because what happens is that obviously these are both planes still, but one of the variables cancels. Right? And so now it won't be the same. So it'll be 2x minus 3z equals negative 4. That's a line now. Is that the answer? Let's take a look. It's a line in the xz plane, but still a line. What question was this? Did not write the question. 19? Yeah, 4.2.19, I'm pretty sure. And I'm scrolling again. Well, of course it's written differently. Okay, so not exactly, but let's see. No, it's not the answer. Never mind. 4.2.19b. Yes, not that. Okay, well, that didn't work. So let's try a different method. Why didn't it work? Probably not allowed to do this. That's probably why it didn't work. Oops. The normal vectors, yeah, the normal. Oh, yeah. That. Let me think about that for a second. Yeah. Yeah. That does make sense. Wait, let me just picture it. Yeah, I guess. Okay, so let's try that. The normal vectors of the normal of the first vector is 3, 1, negative 2. So that's the normal of the first one. And the normal of the second... Yeah. So those are the two normal. Then the direction of our line will be the cross product of this. Now, I try to picture it. I guess that's why. Just imagine two planes intersecting. Their normals sticking out, right? The direction of the line of intersection will be the cross product. Will be perpendicular, right? Because the cross product returns. So if we're doing the cross product of these two lines, then the result of that is perpendicular to both of them, right? So if this was a plane, that was a plane, and I don't know how to draw this. That was a plane. Yeah, that's a bad drawing. That's a bad drawing. I don't know. That did not help at all. But this, to understand the cross product does that. That might be right. I don't know. I'm trying to picture it, and it seems right. So let's do the cross product of this. 3, 1, minus 2, 3, 1, minus 2, 1, 1, 1, 1, 1, 1. So just wrote the coordinates twice of each one. So the first component of the answer is 1 plus 2, so 3. Negative 2 minus 3, negative 5. 3 minus 1 is 2. Okay? That's the direction of our line, is that yeah, that's the answer. Right, that's the direction. And then we probably just need any one point of intersection here. Yeah. Yeah. That makes sense. Whoops. No, I didn't mean to control Z. I meant to control S. Okay. Control C. Control V. Okay, so yeah, let's just try to solve for any one point that's on the intersecting line. So let's just say z equals 0. So this would just simplify to 3x plus y equals 1. X plus y equals 5. Okay, so y equals 5 minus x. Put that into here. 3x plus 5 minus x equals 1. So 2x equals negative 4. So x equals negative 2. And then y is 7. So then, yeah, there we go. So then we have a, yeah, exactly. So we have the direction vector of the line. We have a point on the line. So it's going to be negative 2, 7, 0 plus t times the direction vector 3 minus 5, 2. And there you go. I'd like to see an animation of this cross product thing. I want to see like the planes and their normal vectors, and that they actually are perpendicular always to the line of intersection. Don't know how to draw that at all, so sadly I can't draw it, but I can imagine that there would be a good animation for that. Right, so maybe I'll try to find that. Okay, let's keep going. So I stopped doing practice at 4.2.20. So let's see what's 4.2.20. Why is it crossed out? I didn't do this question. I don't know. Oh wait, no, I'm in the wrong book. No, I'm not in the wrong book. I'm looking at 4.2.40. That's let's see. Find all points of intersection of the given plane and the line that. I did not do this question. I don't know why it's here. So let's give it a try. Somehow I end up crossing out questions I did not do, which is very strange. 4.2.20. Almost couldn't write a 0. Well, let's do B. Start with B. So 4.2.20b is saying, okay, in each case, so the case is where the plane is this, find all points of intersection of the given plane, and this is the given plane and the line. X is equal to 1 minus 2, 3 plus t 2, 5 minus 1. Okay. So one thing we should check. No, that wouldn't do anything. Never mind. Direction vector of the line. Normal. One thing we should check first, I guess, is the normal. 2 minus 1 minus 1. If we dot that with this, which won't do anything in this case. Oh. Will it? I think it might. Yeah, if I dot this, if I take the normal vector, dot it with the direction. Let's see what happens. Right, so sorry, normal is not equal to this, but that's the normal. Dotted with this, so that's going to be 4 minus 5 plus 1. Plus 1. In other words, 0. So since this is just coincidence that it is, as I'm trying to explain this, like as I'm thinking of doing this one check, it actually is helpful for this question. Well, since the dot product is 0, that means that we have a plane, right? It has a normal. The direction vector of the line is perpendicular to it, which means the line's in the plane, which means there's infinite solutions. And again, I hope that's the answer. Let's just see. This was on page 263. Maybe can someone check too? I just did 4.2.20, I think. 4.2.20. None. Okay, none. Oh, I guess never mind. So either infinite or none. Because yeah, sure, the direction vector is perpendicular, but it could the line could also be up here, right? And now, right, still perpendicular, and now it's there's no solution. So how can we tell the difference? I thought it was infinite, but no. So it's either infinite or none. How can we tell? Well, let's choose any point on the plane, and see if that's a point on this line. So, for example, I could choose 0, 0, minus 5. Right? That's a point on this plane. So 0, 0, minus 5. And I'm going to check if that's on the line. So the line was this, right? So I'm going to check if 0, 0, minus 5 equals 1, negative 2, 3. Plus t times the direction vector 2, 5, minus 1. I'm going to check if there's any solutions for t for this. So 0 equals 1 plus 2t. So I'll write this differently. Come on. So t equals negative a half. Yeah. 0 equals negative 2 plus 5t. Right? So t equals 2/5. And notice we have two conflicting values for t, right? So two conflicting values for t, therefore no solution. Right? There is no, this point is not on the line. And so since that point is not, let's just say it's that point, since it's not there, that means that the line is not in the plane, which means it's somewhere outside the plane, which means none. Well, just none. No solutions. Yes, I'm stopping at 4.9 today, yeah. Yeah, in about half an hour. Yeah, I go for another half an hour. Okay. Okay, so there's that question. Let's try D. Let me write the page for the answers just so I don't have to scroll up and down all the time. So the answers are on page 664. This was on 263. And I'm not 263. What? Oh. How did I get to the wrong section? What? Okay, I don't know what I did there. Anyways, I'm somehow in the wrong section. Even though I must have written down the page number wrong. 4.2.20. That's where I'm going. 4.2.20. And we're going to do D. So it's the same question. Find all points of intersection of this line. So D, this line, x 1 minus 2, 3, and t 2, 5 minus 1, right? And the plane. So for D, it gives us negative x minus 4y minus 3z equals 6. Now, of course, they're not going to do it to us again, but let's just check. Let's check the dot product of the normal, right? The normal dotted with the direction vector, 2, 5, negative 1, 2, 5, negative 1. So that's going to be negative 2 minus 20 plus 3, which is not equal to 0. Okay, so that means that it's one solution, pretty much. That means there's one solution, right? So what is that one solution? Let's see. So what I'm imagining is I can break this into x equals 1 plus 2t, y equals negative 2 plus 5t, z equals 3 minus t. I can plug that into here. It would get me a solution for t. Yeah, that might work. How would that ever not work? Oh, if that went to 0? If that side went to 0. No, but then one of the terms would have to be 0. No. Oh, yeah, if the t's canceled out. Okay, so let's try that. So the equation was negative x minus 4y minus 3z equals 6. And so my value for x was 1 plus 2t. So negative 1 plus 2t minus 4 times negative 1 plus 5t, negative 2 plus 5t. And then minus 3 times 3 minus t equals 6. Let's try to solve for t. So negative 1 minus 2t plus 8 minus 20t minus 9 plus 3t equals 6. So then this is negative 19t equals, so that's all gone, negative 2, so 8. So t equals 8 over negative 19, like that. We found a value for t. I'm going to assume you can just plug that into here. So let's take our line again. X is, I'll have it here. So 1, negative 2, 3, just reading off the screen here. Plus, so t is negative 8 over 19 times 2, 5, negative 1. So let's find this out. So the x value of the point is 1 minus 16 over 19. So 1 minus 16 over 19. 16 over 19, 3 over 19, 19. Y is negative 2 minus 8 times 5 over 19. Negative 78 over 19. And z equals 3 minus, 3 plus 8 over 19. So 65 over 19. Doesn't seem like a very clean answer, so who knows, but that's my point. That's the point that I think it is, based on this. Yeah. Oh, let's check the answer, I guess. So again, I have to go to the answer, 6.664. Again, the page number is wrong for some reason. Oh, maybe I read the wrong thing. Yeah, I probably read the wrong thing. 6, 6, 4. So I just did, what did I just do? 5.2 point. Yeah, what I said. Oh, no, not quite what I said. Probably just missed a 1 here. Then it's what I said. I just, somehow it's 13. I wrote 3. I probably just didn't write the 1. And everything else is right. So there you go. That is the answer. All right, so what I did is I took the vector form of the line, put in parametric, put that into the equation, solved for t. When would that not work? Well, when would that not work? Well, if there wasn't an intersection, then the t's would somehow cancel out or something like that. Somehow you would, not just somehow, the t's would cancel out. And then you wouldn't be able to solve anything. And then obviously then you would know, okay, well then there's no point of intersection. We did that with the last line, for example. Okay. Any questions about this one? If not, I will go to 4.2.21, which is not crossed off, which means I haven't done it, but I haven't done these ones either. I don't know why they were crossed off. So that's just how it is. 4.2.21 is over here. Oh, I did some of these. Then I must have just crossed the wrong ones off. Yeah. So these ones were weird. So 4.2.21b is find the equations of all planes that follow this what's the word? Condition. So the first condition is per, not prepare, per, wow, I can't spell. perpendicular to the line x is equal to 1, 0, minus 1 plus t 3, 0, 2. Okay, so to do this, I might look at my old solution for a second. Hold on. Perpendicular, so we're not just looking for any one plane. We're looking for plane or line? Plane. So find all planes perpendicular to this. Okay, if it's perpendicular to this, then so our plane is ax plus by plus c equals 0. Plus zz equals 0, or equals d. Sorry, not just 0, equals d. So we know that a, b, c, that vector dotted with 3, 0, 2, we know that equals 0. In other words, we know that we know that 3a plus 2c equals 0. This isn't going to be right now. Let me look at my solution before. This one? No, that's my test. 1 practice. Okay. 4.2.21. Let's see. This one, B. Oh no, I'm doing B. Perpendicular to that. That doesn't make sense. What? Perpendicular to that line, so it has the same. Oh, wait. No. Find the equation of all planes perpendicular to that line. Oh, so no, that still doesn't make sense. Yes, it does make sense. Yes, it does. Never mind. Okay, I was overthinking this one way too much. So, where are we? Oh no, study group, this one. Yeah, I was overthinking this one. We have a line, right, with a direction vector d. We want all the planes perpendicular to it. Well, all that is that it's all the planes with a normal, which is the direction vector, right? So the normal is going to be, so it's going to be 3x plus 2y equals d, and I'll just put in that point. So it's going to be 3 times 1 plus 0 times 0 plus 2 times minus 1 equals d. Oh, no, but actually it's all the planes. So the only criteria is that. So it's any number d. Sorry. If you're looking for a particular plane that was perpendicular and also went through that point for some reason, but any plane, any value of d here, it'll be perpendicular to this line. Okay, let's look at D. So all planes containing the line that. So this one, you had to use a scalar form of a plane, right? So it's going to be A x plus B y plus C z equals D. So this specific one, if I use that point, 3, 2, minus 4, then what I know is that this will be true, and I'll write it first and then explain it after. So x minus 3 plus b y minus 2 plus c z plus 4 equals 0. Right? Because, well, try it. Plug the point in. 0, 0, 0. It'll all go to 0, so that'll be equal to 0. So we know this is true, right, of this plane, because we know the plane has to go to that point. So now I've created a plane, coefficient with normal ABC, that has that point in it, right? And so now I can just start multiplying in. So ax minus 3a plus by minus 2b plus cz plus 4c equals 0. And then I just want the ax plus by plus cz, right? So ax plus by plus cz equals, and move everything else to the other side. So 2b minus 4c plus 3a, and that looks like it should be it. So ax plus by plus c, that's our plane with the normal ABC. And the number, I always say coefficient, I mean the constant, is that combination of a, b, and c, which will create some number, and a. So those are all the planes that contain 3, 2, negative 4. Let's try F. So they have to contain 2 points. They have to contain, it has to contain the one plane. Well, sorry, all these planes have to contain, okay, 2, negative 1, 1. So P, which is 2, negative 1, 1, and Q, which is 1, 0, 0. Okay. How did I do this before? I'm gonna look at my thing from before. 141 practice. D I did. F. Oh, I did finish it, so let's see. So it must contain PQ. Good. Say that N is. Oh, okay. Okay, that makes sense. So if I go back to study group here. Okay, first of all, we know the plane has to contain PQ. So let's put that in first. PQ is equal to Q minus P. So 1 minus 2, negative 1. 0 plus 1 is 1. 0 minus 1 is minus 1. Okay, so we have PQ. Okay, so we know it contains that. We know that the normal is ABC. Well, we can just call it that. And what we know is that ABC dotted with negative 1, 1, negative 1, we know that's equal to 0. In other words, negative A plus B minus C equals 0, or C equals B minus A. So we can rewrite the normal as A, B, B minus A, because C is equal to B minus A. Let's put this into an equation. So it'll be AX plus BY plus B minus A Z. Right? Didn't have to write Z like that, but it's okay. Equals D. So all these numbers are just A, B, and C. Well, A and B are just numbers, right? They're just some number that we don't know yet. And so to find so first of all, this is just the equation of a plane that is perpendicular to this right here. There's lots of those. Right? But let's put in a point. Let's put in, in fact, there's infinitely many of those, but let's put in this point, 2, negative 1, 1. So I'm going to put in P, which is 2, negative 1, 1. So to do that, the same method as before. So A, x minus 2, plus B, y plus 1, plus B minus A, Z minus 1 equals 0. Not D anymore, 0. We know that this equals 0 because that's the point we're putting in. And now we can expand. So AX minus 2A plus BY plus B plus BZ minus B minus AZ plus A equals 0. Okay, so what do we want to keep on the side? AX, BY, BZ, this one, these three, everything else we want to throw over. Right? So AX plus BY, and I'm going to write this as plus B minus AZ, right? Because I can just put these together and then factor out the Z, right? And that's equal to, first of all, these cancel. And that's equal to A. And that's your equation. So we're looking for any plane where the normal is some number A, B, B minus A, equal to a, the first of the normal, the first number of the normal, all of those planes that satisfy that will be containing those 2 points. Because it has the vector from P to Q, right? So it must have both, well, it must have, well, it must be going in the same direction as P and Q. And since it has P, right, then it has PQ, right? That exact distance PQ, which means it must have Q, right? So if we don't include the point, like maybe this is PQ, then it could be like a plane up on top over here, right? It still has PQ, but when I put in that point, I'm pretty much putting in P, so it must be down here now. And since it's here, it's going in the same direction as PQ, it has P, it must also have Q, and every other point between them, and now a whole plane of points. Right, yeah. Okay, that was F and H. So we want the equation of a plane containing the line x is equal to 302 plus t times 1 minus 2 minus 1. So okay, actually kind of similar to the last question. So we know the normal to our plane is going to be ABC. We know that ABC dotted with 1, -2, -1 is going to be 0. And so based on that, we know that a minus 2b minus c equals 0, or that a minus 2b equals c. So really our vector, our normal vector, is a, b, a minus 2b. Okay, we've included now that the normal has to be perpendicular to this one. So let's write that out. ax plus by plus a minus 2bz equals d. Well, we want also to include this point, 302. So let's include it. A x minus 3, okay, plus by plus 0 plus a minus 2b z, and what was it? And 2. So minus 2 equals 0. Right, that's a 0 here. Okay, so this is, what is this? ax minus 3a plus by plus az minus 2a minus 2bz plus 4b equals 0. So what do I want to keep? I want to keep ax, by, az, this one, negative 2bz, everything else I can throw over, just some number. So ax plus by plus az minus 2bz equals 2a minus 4b. Oh, plus 3a. Oops. I'll write that again. So 5a minus 4b. And here, well, I can factor out something. I can factor the z from both of these. So ax plus by plus a minus 2bz equals 5a minus 4b. And there we go. That's the equation of a plane. That is the direction vector. The ABC is the normal. I dotted it with the direction vector. Right. And well, because if a plane contains a line, then the normal to that plane is perpendicular to the direction vector of that line. Right? Does that make sense? Right? Maybe I'll draw it better, but yeah. Here, if I can. No, it doesn't. It doesn't have to be C. No. But doing that includes the fact that it has to be perpendicular into the normal. Now it's not just any numbers A, B, and C. It's specifically A and B, and then A minus 2B. Any vector, yeah. You put into this, and then put the point in, right? And then just rearrange, solve, and yeah, simplify. No problem. Okay, probably got time for one more. So that was, I can cross this one off. 21. 4.2.23. Let's see what that is. Unless someone has a question they want to throw at me. Shortest distance between the following pairs of parallel lines. Yeah, these were tricky for me. I don't remember how to do these. And 24 was not any easier. They're non-parallel lines. Didn't make much sense to me, the explanation, so maybe I shouldn't be explaining those. Let me just quickly look ahead. 4.3.3b. 4.3.3. Find two unit vectors orthogonal to both u and v. Well, that's not that hard. 3.4. Find the area of the triangle with the following vertices. Oh, it might just seems like it's just more cross product questions. So does anybody want me to do a cross product question, like how to do the cross product? Because I've done one of those. I did one of them here, but that's it. If people are confused how to do the cross product, or like with the like the method with the two lines, just let me know. Or say in the chat. Let's see. Did someone say something here? Yeah, 8:45. Well, so 15 minutes ago, pretty much, someone said, "Isn't it 2z since y is 0 for b?" Yeah, I know what you're talking about. Where is it? Here. For here? Oh, for part. Oh, sorry, for part B. Part B is here. Yes, it's 2z. Yes, it is 2z. I don't know why I said 2y. Yep. This is 2z. There. Good. Yeah, do you have someone have a question? (4.3.2). Yeah, I'll take a look. So 4.3.2 is 4.3.2. It says, okay, so 4.3.2, show that u cross v cross w does not need to equal u cross v cross w by calculating both. So let's do that. Okay, so first of all, let's calculate this, right? So u cross v cross w. So v, I have the vectors here. I won't, well, I guess I'll write them here. So u is 1, 1, 1, right? V is 1, 1, 0. Should write the question. Oh, I did already. And w is 0, 0, 1. Okay, so let's start with this. U cross v cross w. So u cross v cross w. Let's figure what that is now. V cross w is going to be 1, 1, 0, 1, 1, 0, 0, 0, 1, 0, 0, 1. So it's going to be 1 minus 0, 0 minus 1, 0 minus 0. So that's that. So it's going to be 1, negative 1, 0. And now I'm going to find what u cross that is. So u is 1, 1, 1. So u cross this. 0 plus 1, 1 minus 0, negative 1 minus 1. Okay, so our answer for this first part, right, is 1, 1, 0. Okay, and then let's try to check that with the second one. Let's see if u cross v cross w, see if that's the same thing. So now first we got to find u cross v. So that's going to be 111 cross 110. 111, 111, 110, 110. Okay, so 0 minus 1, 1 minus 0, 1 minus 1. Okay, so that's this. I'm going to cross that with W, 0, 0, 1. So negative 1, 1, 0, negative 1, 1, 0, and W was 0, 0, 1. Okay, so this cross product will be 1 minus 0, 0 plus 1, 0 minus 0. Okay, and so you see, crossed by U was 1, 1, 1. Sorry, I didn't write it very clearly. This was our answer for the first part, 1, 1, 0. Oh, and it's the same thing. Okay, that's not what I showed that U cross. Oh. Okay, it's a weird phrase. Show that U cross V cross W need not equal U cross V cross W by calculating both. They are the same. They got the same thing. They got me the same answer. I don't really know what else they want for the question. So there. Yes, they got the same answer for me. So yeah, again, I don't really know what else they want. Yeah, so here, I'll do one slower. So let's say I'm trying to cross these two. I'm going to make up some better vectors. So here. Yeah, here, I'll just choose from a different question. So let's say I'm trying to cross W, which is 2, 1, 1, right? And I'm trying to cross V with V, which is 1, 0, 2. Okay. So let's say I'm trying to find V, specifically V cross W. Okay. Probably should have said W cross V, but it's fine. V cross W. So I write my first one, 1, 0, 2, 1, 0, 2. I write it twice. Okay. This is like the trick to do it. This is how you do it fast, right? 2, 1, 1, 2, 1. I write my second one twice, right underneath. Cross out the first and the last column. And then what I want to do is each component will be the determinant of these matrices. So here, I'll do it like this. So the first component will be the determinant of that matrix. The second component will be the determinant of that matrix. And the third component will be the determinant of that matrix. So our answer, so right, the cross product always returns a vector as an answer. So the first component will be the determinant of 0, 2, 1, 1. Second component will be the determinant of 2, 1, 1, 2. And the third component will be the determinant of 1, 0, 2, 1. And so I just figured this out. Right, so the determinant of 2 by 2 matrices is this times this minus this times this. So 0 times 1 is 0, minus 2. So that'll be negative 2. 2 times 2 is 4, minus 1 is 3. 1 times 1 is 1, minus 0 is 1. So that's the cross product of these two vectors. V cross W is negative 2, 3, 1. And there you go. So does that make sense as to how I do it? Yeah. Well, you won't really cross three vectors at the same time. Like you wouldn't do V cross W cross U or something like that, because then you'd have 3, right? You'd have a row of 3, but generally you do one at a time, right? So that's what you would just do one at a time, and then you'd have that. Cross product is only defined in R3. Maybe that answers your question better. Yeah, cross product is only defined in R3. It is defined in other ones, but not that we're going to use it. And there's like other tricks you have to do, and the main definition is in R3. And so then you can do this, right? So the determinant of those two things, right? Maybe I'll leave this up here. But unless anyone has any other questions, then that's it for today. 9 o'clock. I did enough. All right, no problem. Yeah, no problem. I'll have another one on what day? Wednesday. Yes, Wednesday at 6:15. And then that's when we're gonna start doing 4.10. Okay. Yeah, and 4.11. Yeah, and 4.11. But that's a whole other thing, whole other can of worms. So it's gonna be, it really is. So yeah, that's why I wanted to separate it. So this was just all the stuff that's not 4.10, and then Wednesday we start 4.10 and 4.11. Okay. Okay, so yeah, so I'll be here for a few, just like 2 more minutes. Anyone can ask me questions. Other than that, then have a good night. Good luck to everybody. Maybe for the last minute, I'll just do a little bit of this. A little bit of this going around. Pretty cool. I will stop recording because I forgot to stop recording last time and I had to cut it.